Hello everyone. In this video, I will discuss the laws of exponent. To start off, let's first define an exponent. When we say exponent, or the exponent of a number, says how many times to use the number in a multiplication. For example here, 2 raised to 3. So this 2 here is your base, and the number in the upper part of number 2 is your exponent. So this exponent would be basis of how many times this base will be multiplied. Since 2 is multiplied in 3 times, so this 2 is, or 2 to the power of 3 is just equal to 2 times 2 times 2. Or, or 2 will be multiplied itself 3 times. So meaning 2 times 2 times 2. So of course the result is 8. Not 2 times 3, but instead 2 times 2 times 2. So again, 3 is the basis for the number in multiplication. Now, let's tackle on the best basic laws of exponent. First is the zero exponent law. So it's stipulated here that x, or quantity of x n raised to 0 is equal to 1, or any base raised to 0 is equal to 1. So regardless what quantity inside the parentheses, but it is enclosed entirely by exponent 0, the result must always be 1. Okay, let's have an example here for the zero exponents law. Like for example, y to 0 exponent. So the answer is 1 because the exponent of base y is 0 irregardless what quantity. Since y raised to 0, it is always equal to 1. So 1 is the answer. Now, another example, this time quantity of a plus b raised to 0. So, same with problem 1 or example 1. So the answer is 0 is 1 because the whole quantity here is raised to 0, exponent 0. That is why the answer is 1. So final answer is 1. That is zero exponent law. Any base raised to 0 is always equal to 1. That is for the first law. Second, this time multiplicative law. So what does multiplicative says? Or how to operate multiplicative law? You just simply add the exponent when multiplying two powers of the same base. So this that represents or means times or multiply. Then before you apply the adding of the exponent, you check first if they're bases. So for the first variable here is x. then the other one, or the number that is multiplied is x also. So you just simply copy its base and then add their exponent. So assuming m exponent, n exponent, whatever be the exponent m would be added to exponent n, provided that they have the same base. So that is x raised to m plus n. So this is the formula. So in case that this is x and this is y, you cannot combine the two variable. And you cannot add also their exponent since they have different base. It should be the same base before you add their exponent. For the multiplicative law, example, z4 times z raised to 6. So first, you need to check. So we have an answer already here, but we will discuss how I come up with z10. First is I check first the base. So you have a base here, z and c. So it satisfies the requirements that they must have the same base. So you simply, excuse me, add the exponent 4 by exponent 6. So therefore, 4 plus 6. And then simplifying further, that is z10. So the answer is z raised to 10. Next. So another example here, a or quantity of ab raised to negative 4 times quantity of ab raised to 5. So this ab now would be your base. Same with here, base. So the answer is ab. So first is you need to check their bases. Then, okay. So with that, you add the exponent, negative 4 and 5. Since their bases are the same. So you add their exponent, negative 4 plus 5. So with that, we come up negative 4 and plus 5. So simplifying negative 4 plus 5, that is 1. Or simply A, B. So that is the answer, AB. So it should be the same base before you add their exponent. And in adding exponent, you go back now with the operations of real numbers, the one that I'm discussing in my previous modules. Now, for the third law, power of a power law. So this time, the rule says that you multiply the exponent in simplifying any power of a power. So you have an exponent here, you raise to another exponent. All you have to do is to multiply the exponent, their exponent. So the dot here means, again, times. So all you have to do is to multiply, copy the base, x here, and then you multiply the exponent, n, m to n. So multiply or times. Do not forget for that. Do not add. So this is the rule for power of a power. Let's have an example for that. Power of a power law. So first, the quantity B5 raised to 3. So this is your base. Then the base 5 has an exponent of 5. So raised to 3. So how it is being solved? So the answer daw po ay B15. And now how do I come up B15? So you multiply their exponent. So 5 times 3 is 1. And this 1. So 5 times 3, that is 15. Or B raised to 15. So that is now your answer. Power of a power law. Next. The power of a power law, example number 2. So this time W raised to n plus 2. And the whole quantity multiplied by 4. So your n plus 2 is your exponent. Then you multiplied it to your 4. So this is how I solve for that. The answer daw po ay Wn 4n plus 8. So first is you need to multiply your exponent here is 1. And then by the outside exponent 4. So you can do like this, 4 times n plus 2 or n plus 2 times 4. That is commutative property of multiplication. That if you have A times B, it is just equal to B times A. So you can write this one, or you can first write n plus 2 then times 4. Then you have 4 outside the parentheses. That is for distributive property. So you distribute the number outside to the inside parentheses. So 4n. This is 4n. And then 4 times 2. That is 4 times 2 here. Of course, plus between. So simplifying further, that is 4n plus 8. And that is now your final answer, which is W raised to 4n plus 8. So although my first example, it involves only pure numbers, but this time the exponent m is n plus 2. So you multiply exponent to exponent. That is 4n plus 8. So quotient of a power's law. So it involves quotient. So for that, this is the rule. In dividing powers with the same base, simply copy the base and subtract their exponent. So again, before you divide the exponent or subtract the exponent, make it sure that the same base. So x and x. So they must have the same base. So same as what I am discussing in the previous law, that if this is x, yeah, this is y, you cannot do the law, or you cannot simplify for that. So it must be the same base. So since if it qualifies that the two variables have the same base, then you subtract the exponent of the numerator by the denominator. So xm minus n. If m is greater than n, that is for quotient of a power. So copy the base, subtract their exponent. Subtract their exponent. So m minus n. So that is for your quotient of a power law. Next. So let's have an example. For example, you have y raised to the power of negative 8 divided by y raised to the power of negative 10. So, check first if their bases are equal. So, as you have noticed that same base y here, both numerator and denominator, then proceed to the subtraction of the exponent, or you subtract the exponent of numerator by the denominator. So, this is how I arrive. The answer now is y squared. So, y negative 8 subtracted by negative 10. So, this is negative 8 minus 10. And then, negative 8 plus 10 is equal to 2 by operations of addition, y squared. So, the final answer would be y squared. So, that is your final answer. Quotient of a power example law, another example. So quotient, this time it involves variable. Although this is more complicated, but this is just simple solution. Or it is just an easy example. But it involves a variable. So this is quotient. Check first their bases. Check, correct. Now, if yes, then you proceed to the next step. For the solution of that, this is 5 plus n, then minus n plus 4. So, it should be a quantity, n plus 4. Take note for that. Do not minus n plus 4. So, this is 5n, which is the exponent of the numerator, minus the exponent of the denominator. So, we have 1 outside here. So, negative is being distributed to the inside parentheses. That's why we have here minus n minus 4. So, simplifying further, 5 plus n minus 4. So, your n here will be cancelled because n minus n is 0. The remaining is now 5 and 4, negative 4. So, 5 minus 4 is equal to 1. Right? 1. 5 minus 4 is 1. Or, we say that it is equal to x. Understood that if you have x, the exponent or degree of that is 1. So the final answer is x. Next, negative law exponent. So the negative law of exponent, first case, this is the upper one is this one. This is the first case, and then this is the second case. So for case 1, if the exponent is in this form, x raised to negative n. So as you have noticed, it goes down, but the exponent is changed to negative, positive, I mean. So again, if the exponent in this form is this one negative, it goes down. In the other way, if the exponent is in the denominator, it goes up, but again, the same, it changed to positive sign. So in short, from negative to positive, then if it is in the denominator, then it goes up. Same, it changed to positive. Remember that in simplification, answers is not simplified if there is still a negative exponent present in the answer or solution. So it is not yet simplified if you have answer x negative 5. So the base will become reciprocal with the positive exponent if the base is powered by the negative exponent. So let's have an example for that. B negative 8. So, so it is in the denominator and numerator over 1. So therefore, the negative here would be goes down. It goes to the denominator. So that's why we have 1 over the whole quantity b raised to 8. So the negative here would change to positive, but it goes down, or it goes in the denominator. That is why the answer now is 1 over b8. So this is the answer. Another example. So by the way, the example that I'm presenting first is case 1. This time, negative 2 over x negative 5. So how do I solve for the answer negative 2x5? So we have here negative 2 and x negative 5. So take note that this negative 2 is not an exponent, but rather this is a constant. So you do not write negative 2 in the denominator, since negative 2 is not an exponent. You can go moving of exponent, you can do moving of a variable if the exponent is negative. But if the constant value is negative, then you cannot go down for that, or you cannot go that negative to down or from down to up. So that is why negative 2 will remain as constant negative 2. And then, since negative x5 here is negative, so it goes up. And then this is 1. This whole quantity x negative 5 will be goes up, but change to positive sign. That is case 2 over 1. Or simply negative 2 x raised to 5. So that is the final answer. For the next law of exponent, that is problem number 2, 20a negative 1 all over negative 10, b negative 2, c negative 3. So you can simplify by doing this. So you can do right in this way. First is you manipulate first the constant 20 and 10 here. 20 and negative 10. So this negative 10 would not goes up because again, this is not an exponent, but rather this is a constant. So it remains at the denominator. So 20 divided by negative 10, that is negative 2. And then for case 2 and case 1, first, these 2 here, negative b and c. So their exponents are negative. So it goes up. But their sign will be changed to positive since negative here. So it goes up, then positive. In the same manner, for a negative 1, it goes down. So it will become positive here. And then, this is now your final answer because you cannot divide b by a and c by a. And you cannot also divide constant negative 2 by a. So this is now your simplified answer, which is negative 2b squared c cubed all over a. So this applies case 2. So this one goes down, and then this 2 here goes up. So it involves case 1 and case 2. Okay? So the final answer is this. Now, next, power of a product law. So you have two variables or expression inside the parentheses, and then the whole quantity here raised to n. So the rule says that in order to find a power of a product, find the power of each factor and multiply. So meaning this n here would be distributed to the inside, so xn. Of course, the operation is multiplication times yn. So it involves constant here and a variable, so the constant would be raised to n and variable raised to n. So that is for the power of a product law. For example, 2x4 raise the entire quantity by cube or 3. So with this, the answer daw po ay 8x12. So how do I come up 8x12? So first, you distribute. So this is your x daw po, this is 2. So 2, or the cube would be distributed to the inside. So 2 raised to 3. And x4, this 3 also is distributed to x4. So this is x4 raised to cube. So it is being distributed to the inside. So finally, 8. So this is 2 cube. So this is an exponent. So the exponent tree would determine how many times you repeat 2. So meaning 2 times 2 times 2. Do not do 2 times 3 because that is wrong. It must be 2 times 2 times 2. So the 3 would be your basis for how many times you multiply 2. So 8. And then, excuse me, x4, x12. So this is exponent to exponent. So exponent to exponent, 4 times 3, that is 12. And then 8x12. Again, you cannot combine 8 by x12 because this is not a variable. So this is now your final answer, which is equal to 8x12. So again, thank you for listening to this video. This is Engineer Larry Angelo Arcagnetti, your mathematics and statistics reviewer for SNRC or Santo Niño Review Center. Thank you for listening. And I hope that you gain something, you learn something. Again, in mathematics, it is very important that you keep on solving. Practice makes perfect. And of course, in order to solve math easier, so you need to love also math. Thank you, and God bless everyone. Salamat.